All right, let's talk about something that drives every single person crazy when they first start using Jupyter Notebooks. We're going to solve one of the most common, most frustrating errors out there. And then we're going to look at how you can stop doing all this tedious manual work and start building your data structures like a pro.
First up, let's dive into this very common problem, the mysterious name error.
Okay, so you know the feeling, right? You open up a notebook you were just working on. All your code is there, it looks perfect. You can even see the old output sitting right there below the cells. Everything looks ready to go. But then you try to run a cell, maybe somewhere in the middle, and bam, you get an error.
And this is what you see. Name error, name array__2D is not defined. And you're staring at the screen thinking, what? I can literally see the cell right above this one where I defined that exact variable. So why is the notebook telling you it doesn't exist? Trust me, this is the moment that drives beginners nuts, but the fix is actually super simple once you get what's happening behind the scenes.
See, the solution to this whole mystery lies in one single crucial concept at the heart of how Jupyter works, and that concept is the kernel.
So just think of the kernel as the brain of your notebook. While you had that notebook open and you're running cells, the kernel is the active engine in the background that's executing all your code. And, most importantly, it's holding all of your variables and functions in its short-term memory.
And here is the absolute key. When you close your notebook or shut down the application, that kernel, that brain, gets a complete memory wipe. It's gone. So when you open the notebook back up, the code and the old output you see are just, well, they're just text. They're like a ghost of your last session. The new, fresh kernel has no idea what array__2D is because you haven't run the cell that defines it in this new session. So, how do we fix this? Easy. We just need to get everything back into the kernel's memory by running the code from top to bottom. And the fastest way to do that is to go to the kernel tab right up in the menu bar, and then you just select Restart and Run All. It does exactly what it says. It wipes the slate clean and then executes every single cell in order from the very top to the very bottom. And hey, as it's running, keep an eye on those little brackets right next to your code cells. If you see an asterisk in there, like in star, that's your cue that the kernel is busy working on that specific cell. Once it's done, it'll get a number, like in 1, in 2, and so on. That number shows you the exact order everything was run in. And just like that, no more name error. Okay, perfect. Now that we've got our workflow fixed, let's build on that and tackle another core data science task, creating matrices. But first, to really appreciate the easy way, we're going to take a quick look at the hard way.
So let's say our goal is pretty simple. We need to create a 3x3 grid, a matrix, where every single spot is filled with the number 1. Now, if we were only using standard Python lists, we'd have to build the whole thing by hand.
And it would look just like this, a list that contains 3 other lists inside of it. Now, for a tiny 3x3 matrix, this is okay, but can you imagine trying to do this for a 100x100 matrix? It would be an absolute nightmare of typing, and you'd be almost guaranteed to make a mistake somewhere. There has to be a better way. And of course, there is. It's time to introduce you to your new best friend, and one of the most fundamental libraries in all of data science, NumPy. Now, here's the aha moment. This isn't just about writing less code. NumPy is ridiculously fast because it's built on lower-level languages and it handles memory way more efficiently than a standard Python list ever could. Just look at the difference here. On the left, you've got that tedious manual list of lists, and on the right, that's the NumPy way. After a quick import, it's one single readable line of code, np.ones 33. This one command does the exact same thing as all that typing. It's clean, it's clear, and it is so much more powerful. And np.ones is just the beginning. NumPy gives you a whole suite of these power tools. np.zeros does exactly what you think, fills the matrix with zeros. And then you have np.empty, which is a really interesting one we'll look at in just a second. And a quick heads up, by default, all of these create floating point numbers. Okay, here is a quick but absolutely invaluable pro tip. If you ever forget how a function works or what kind of arguments it needs, just type its name in a code cell, hold down Shift and press Tab. A little window will pop right up with all the documentation right there inside your notebook. Seriously, it's a game changer for learning and just exploring. And what's really cool is how much you can customize these. You pass in a shape like 4,6 to get 4 rows and 6 columns. But you can also specify the data type with the dtype argument. So if you want integers instead of floats, just add dtype equals int.
You can even create matrices of booleans, where all the zeros become false, or even a matrix full of empty strings.
All right, for our last little bit here, let's quickly peek under the hood at that third function we saw, np.empty, because understanding this one little detail is going to save you from some really confusing bugs later on. And this is the big reveal. The function np.empty is, well, it's very misleadingly named. It does not create an empty matrix. Instead, what it does is it just grabs a block of memory for you, and it's filled with whatever random garbage values were already sitting in that spot on your computer.
So you're probably asking, why on earth would anyone use this? And the answer is just one word: speed. Because np.empty doesn't waste any time initializing those values to 0 or 1, it is the absolute fastest way to create a new array. You should only use it when you are 100% certain that your very next step is to fill in every single value of that matrix with your own data.
So let's wrap this up. You now know exactly why that name error happens when you reopen a notebook, and more importantly, how to fix it in seconds with Restart and Run All. You've also seen how to ditch all that tedious manual typing and use NumPy to create any size matrix you want in a single line of code. So the only question left is, what are you going to build first?